Hello everybody. In this Python tutorial we're going to go over how to find combinations and permutations. A couple of quick notes before we start. Combinations are arrangements of objects without regard to order, selected from a number of objects. Permutations are the number of possible arrangements in an ordered set of objects. If the order doesn't matter, it is a combination. If the order does matter, it is a permutation. So we're going to go over examples of how to find permutations, combinations with replacement, and then we'll show an example of combinations versus all possible combinations. So in this example, we will get rid of the specified number of objects we want when we determine our combination. So it will be all possible combinations for all possible lengths of elements in the data set. Okay, so what we'll do is I'll go ahead and type out the code for each example and then we'll go over it. The first thing we want to do is import the Itertools module. Now let's go ahead and move on to our first example with the permutations. Okay, so the first thing we did to find our permutations is we created a variable. We named it permute, and then we assigned the Itertools module. We used a dot to access the permutations function, and then inside the round brackets for the permutations function, we put the data that we want to find the permutations for. So in this case, for the first argument, we used a range to put in our iterable, and this will be numbers from 1 up to, but not including 7. So it will be a range of 6 numbers, and from those 6 numbers we want to find the permutations for lengths of 3 or sets of 3. Now, a really cool thing that we're going to use throughout this tutorial is if you want more information on a module or a function and you're using the Spider IDE, you can go ahead and you can click on it and then you can hit Command I. Okay, so if you want to see the arguments that go into the permutations and other information, you can click on it and then hit Command I for information, and you can see over here in your help screen it gives you the information for the permutations. So as we said, the permutations function takes 2 arguments. The first argument is an iterable, and in this case we just use the range as we said. And remember, when you use a range, in this case it can take 3 arguments, but since we only put 2 in, this will be the start and this will be the stop. And the stop goes up to but not including that number, so again it goes to 6. Okay, back to our permutations help. So the first argument is the iterable, that's our range of numbers, and the second argument r is the length of the set. In this example they put in a range of 3, and then for the second argument they put in a 2, and you can see the numbers that come out are in sets of 2. Okay, so in this example that is the data we're going to use for our permutations. Now just to show you another example here, if you did not want to use a range and you actually wanted to put in a list, you could do that. So in this case, instead of using the range 1, 7, you could just put in a list of numbers 1 through 6. Okay, so the next thing we did is we created an empty list. We called that count permute, and we're going to use that to help us get the final count of the different sets of numbers to find all of the permutations. Okay, then we used a for loop to loop through all of our data here. Then here we access our empty list. We use a dot to append all of the different sets of permutations. And then here we use a print statement to print out all of the different sets of permutations. Now this first part of the print is actually just going to show the number associated with each permutation. So for this example, we should get 120 different permutations. So this code is just going to number each permutation, and then this second I is going to show you the permutations themselves. Okay, and then this print statement here is going to show you the total number of permutations for this data set here. So we went ahead and we put in a little string that says number of permutations, and then we use the length function, which will give us the count of elements in our list. We created the empty list, and then we appended the elements here. Okay, so this print statement will give us the final count of permutations for this data set. So let's go ahead and select our code. Let's close our help screen here, and let's go ahead and run it. And you can see over here in the console we get all of the different permutations. Okay, so as we mentioned, for this print statement here, this count.index code gives us the numbers here on the far left. So this is the first permutation, this is the second permutation, this is the third permutation, and so on, all the way down to permutation 120, okay? And you can see this print statement here just gives us a quick summary. So the total number of permutations is 120. Okay, so now let's move on to our combinations example. Okay, so the first thing we did to find our combinations is we created a combin variable. Then we assigned the itertools a dot to access the combinations function. Let's go ahead and select that and hit Command I so we can see the information for it if you'd like. So here we have the information for the combinations function. You can see it's very similar to the permutations function. It takes two arguments, the first being the iterable and the second being the R length. Okay, so that's the number of data elements that you want to choose from your iterable. Okay, so again, we just used a range of numbers from 1 up to, but not including 11. And from that range of numbers, we're going to create combinations with sets of 3. Now, just to show you, just like in the example above, if you don't want to use the range, you could just go ahead and put in the actual numbers for the first argument, which is the iterable, in a list. So here we have numbers 1 through 10 for the first argument, which is the same as the range of 1, 11. Then again, we created an empty list that will help us get the final count of combinations at the end. We loop through all of our data using a for loop. Our data, again, we created here. Then we access the count combinations list. We use a dot to append all of the combinations. Then we use a print to display, and inside the print to get the number for each combination, just like we did over here on the far left. You can see, for example, this is permutation number 85, and so on. Now, one thing we might not have mentioned above is, so we use the dot index, we put the I inside the round brackets. You notice this +1. If you don't put this +1 here, your count will start at 0. So we went ahead and put a +1 here, okay? Then we put a comma, and then we put an I, which will return all of the different sets of combinations. Then our last print statement here, we put a little string that says number of combinations. We use the length function. Inside the length function, round brackets, we put our list with all of the different combinations to give us a final count. So let's go ahead and select this code and run it. Let's go back up to the top, and you can see over here in the console, over here on the far left, we have given each combination a number, and then we have all of the different combinations. Okay, so this is combination 1, combination 2, 3, and so on, all the way down to the bottom. And in this case, for the iterable that we chose and the length of numbers that we chose, we come out with 120, just like we did in our previous example with the permutations. Okay, so way down here at the bottom, the total number of combinations for this data set here is 120, and if you wanted to see the individual combinations, obviously, you can see all of that data here. Okay, so let's move on to our next example, where we're going to find combinations with replacement. Okay, so the first thing we did for our combinations with replacement is we created a variable. We assigned itertools, use a dot to access the combinations with replacement function, put in our 2 arguments. Let's go ahead and select it and hit Command I so you can see the information. This function is very similar to the permutations and combinations function. You can see the 2 arguments it takes, just like previous examples. The first is the iterable and the second is R, and you can see R is the length or the count that you want to choose from your iterable. Okay, so for our iterable, we used a string of letters ABC, and for our R or length, we used 2. Then, just like in the examples above, we create an empty list. Here, we use a for loop to loop through our data here. Then we use our list and we append all of the different combinations so we can get a total count at the end. Then we use a print statement here. And just like in the previous examples, this will give us the number for each combination, and then this will give us the combination. And for our last print statement, we use a string that will say number of combinations with replacement. We use the length function to give us the count of elements in our list. Okay, so let's go ahead and select our code and run it. And you can see over here in the console, we get all of the combinations with replacement. Now, one thing you'll notice is if you look at the output here, you will see the different replacements, okay? And then finally, we get the number of combinations with replacement, gives us a total count of combinations of 6. Okay, next let's move on to finding all possible combinations. Okay, so the first thing we did to find all possible combinations is create a function. So we use the def reserve word to define the function. We gave the function the name allCombosFunc. Inside the round brackets for the function will take arguments, so we just gave the arguments the name arguments. Then we created a variable called data, and we assigned the arguments to that variable to put them in list form. Okay, so that will put them in a iterable form and make them easier to work with. Then the function will return data in the form of all possible combinations, but we're not done yet. So in just a minute, we'll explain what we need to do to get all the possible combinations. So before we move on, let's explain this code a little bit further. So the first thing we did is we used the iterTools module. We use a dot to access the chain. Now, as we said before, one thing you can do to find out what the chain is or does is to click on it and then hit Command I, and you get the information for the chain. Okay, so the chain is used basically for treating consecutive sequences as a single sequence. I guess you could say, or think of it as chaining sequences together. Then we use a dot to access the from iterable, and that just simply allows you to take data from an iterable. Then inside the round brackets for the from iterable, we use the iterTools module again. Then we use a dot to access the combinations function. We put in our arguments. So we put in the iterable argument, which is the data, and then we put in the length. Then after that, we use a loop to loop through all of the data. Okay, so as we mentioned, we're not done yet. So to use this function and to allow us to display the output, we went ahead and we created a variable, and we assigned the function to the variable, and then for the function arguments, we put in our data elements. So we want to find all possible combinations for the elements of 1, 2, and 3. Okay, next, similar to previous examples, we went ahead and created an empty list here, and that will allow us at the end to get the total count of all possible combinations. Then we use a for loop to loop through all of the data using the function. Then we access our list to append all of the combinations. Then we use a print statement here to print out all of the different combinations. And then finally, we use one last print statement to give us the total count of all possible combinations. So let's go ahead and select our code and run it. Okay, so you can see over here in the console, we get all of the possible combinations here for the data elements of 1, 2, and 3. So you can see here the difference between all possible combinations and our previous examples is that the length of numbers in these sets of data can vary. Okay, so that gives you all possible combinations. And the total number of all possible combinations for the data elements 1, 2, and 3 is 8. Okay, so that's all we have for this Python tutorial on combinations and permutations. We'll be doing many more Python tutorials in the near future. Join us for those, and we'll see you next time.